All right, so when you see a problem like this, there's some ways you can attack it. Okay, I'm going to be writing here with my stylus pen, just some things that you really got to see. So they tell you, let G be the function defined for all real numbers except x equals 2. So they tell you x cannot equal 2. They tell you that. That's a critical point. It says also let G prime, the derivative of G, be defined as G prime is x squared all over x minus 2 to the third power. So they give you some other information there. And what they give you is that you got a critical point right here at 0, and you got a critical point at 2. And so what I like to do to just draw this out for myself so it's just real easy and plain is I allow the bottom to be the derivative, which I know is the slope of the original function, and I allow the top to be the original function. So now I pick numbers. If I picked any negative number, I'd have a negative times a negative on the top. I'd get a positive. Over, I'd have a negative minus a negative, which is a negative number. And then the bottom would still be negative. So that is going to result into some negative number. I don't know what that number is, but I know some negative number. Then I have a critical point at 0, so I'm going to pick a number in between 0 and 2. I'll pick 1. I'm going to have 1 squared. That's going to be positive. And then I'm going to have 1 minus 2, which is negative. The cube root of a negative number is still negative. Okay. So then let me pick another number on the other side of a critical point. Let's say 3. And if I pick that, I have a positive on the top. 3 squared is 9, positive 9. And I'd have a positive on the bottom. So this value that would come out would be positive. What does that tell me about the original function? Well, if the slope is negative, I know it was going downward. I know it was going downward. And then I know it began to increase when the slope was positive. So I know that this is a minimum point. This is a minimum, some relative minimum. We don't know if it's the lowest. I know 0 is a flat point. It didn't change directions. Okay? It didn't change the directions. So now when they ask me the question, on which interval is it increasing, well, it's increasing from 2 on down to infinity, like forever. There's no other critical points. All the way to infinity. All right, so I see my answer. Go ahead and click that, and we got it. I'll try to do one more. Let's see if I have enough time. Okay. Let me move this. They give us h of x is the function on which intervals is h increasing. First thing I want to do is find h prime, and I find that to be 4x to the third minus 6x squared. I need to set that equal to 0. So I know the 0 slopes. That's when it's flat. And at that point, I'm going to have, I can factor out an x squared. 2x squared would give me, what's that? 2x minus 3. Yes, sir. So either x is 0 or x is equal to, that's going to be 3/2. Okay. I needed to know those numbers so that I can go ahead and draw this line. And I know a critical point is at 0. I know another critical point is at 3/2. I know the original function. Okay. So let me pick any negative number. And if I pick a negative number, I'm going to get a positive on the outside times 2 times some negative minus 3. I'm going to get a negative number. So I know that slope is decreasing. Okay, let me pick a number like 1. If I pick 1, then I will have a positive on the outside, a negative on the inside. It'll still be negative. And if I pick some value greater than 2, I'd have a positive on the outside and a positive on the inside. So that thing is positive, it's increasing. So